So yeah, Leetcode 1306 Gem Game 3. Okay. So the problem statement is like given an array of non-negative integers. Okay, non-negative integers ARR. You are initially positioned at start index of the array. Okay, when you are at index I, you can either jump I plus array of I, that is we can jump I plus array of I forward, or I minus array of I, which is basically backward. Check if you can reach to any index with value 0. So notice that you cannot jump outside of the array at any time. So we cannot go out of bounds. That is, we cannot go backward below 0, or we cannot go forward above the boundary of the array. That is the length of the array. So let's take the input. We are given an array 4 2 3 0 3 1 2, and our start is 5. Okay, yeah, okay, so 0 1 2 3 4 5, we are starting from here, and from here we can either jump I plus array of I or I minus array of I, and from there again we can jump I plus array of I or I minus array of I. So here if we again so from here 1, we can either jump to 2, that is 1 plus 5, or I minus array of I. Okay, so here we will reach 2, here we will reach this 3. Then from here we cannot jump forward, but from here we can jump backward 3 position, then forward 2 position, so that we will be reaching the index. Okay, so so we will be reaching the index where the value is 0, so we can return 0 in that case. We can return true in that case. Now the next, we are starting from 0, we cannot move backward. Okay, we can move 4 steps forward, so 1 2 3 4. Okay, from here we can either jump I minus 3 backward or I plus 3 forward, but I plus 3 is not possible, because if we jump 1 2 3, it becomes out of bound, so it's not possible. But we can jump backward 3 position, 1 2 3 and 2 position forward, so we again reach a 0, and this is the same way we will not be able to reach. Okay, so let's take an example and try to get it more clearly. So let's take this first example. So we are having 4 2 3 0 3 1 2. So it's given if we are at a position I, we can either jump I plus a of I, where a is the array, or I minus a of I. So this is the two possible jumps that are possible from a particular index. So let's say this is 0th index, this is first index, this is second index, this is third, this is 4 5 6. So we are starting, this is our starting position. Okay, from this we can jump 1 step forward, okay, and 1 step backward. After making the jump, we can say we visited this one time, we visited this one time, we also visited this one time. So in future steps, if we fall again to any of these nodes, it says that no matter how many times we make the jump, we make the jumps, we will be again ending up in the same position, which will create an infinite loop, and we will not be possible to reach the index that is having a value 0. So that is one condition in order to say that we will not be able to reach that index with value 0. So yeah, let's continue. So now we are at this position, say, okay, from here we can move 2 position forward, but it is out of bounds, so that is not acceptable. We can move 2 position backward, but this is already visited, so that is also not possible. So now we are done with this node, but from 1 we can also reach 3. So from 3 we can move 3 steps forward, but if we move 3 steps forward we are going out of bounds, so that is not possible. So what is the other configuration we are having? We can move 3 steps backward. So if we move 3 steps backward, we reach this position and we can mark this as visited. Okay, now this is our current node. Now from this we can make 2 steps backward, but if we make 2 steps backward it is again going out of boundary. So the other possible configuration we are having is 2 steps forward, and when we make this move and check what is its value, what is this value? Its value is 0. So that's it. If we get that value we can directly return true. So that's the about the first example. We can also check the next example. Okay, now this is the next example. The same numbers: 4 2 3 0 3 1 2. So we are starting from these are the indexes: 1 2 3 4 5 6. Okay, this is 3. Okay, so we are starting from this 4, so we can mark this as visited. Okay, now from this 4 we can move 4 steps backward, but we are going out of boundary, so that's not taken care. We can move 4 steps forward. Okay, 1 2 3 and 4. Okay, now we reach this position. Now this is marked as V. Now from this node, from this 3 we can move 3 steps forward, but that is not possible. We are again going out of bounds. So our other possible configuration we are having is 3 steps backward. So we reaches this node 2 and we can mark it as visited. Now the other configuration we are having is 2 steps backward, but 2 steps backward is making us going out of bound. So we are having 2 steps forward and we again reaches this node. So if we reaches the node or the index with a value 0, we can return true. Now what is the false condition? Now let's make this a false condition. So let's look at that. So 3 0 2 1 2. And what are the indexes? This is of index 1, this is 1, this is 2, this is 3, and this is 4. Okay, so we are starting from this node. Okay, 2 steps. Okay, this is marked as visited. Okay, now from this we can move 2 steps forward. Okay, and 2 steps backward. That's possible. So if we move 2 steps forward, we reaches this node and we can mark it as visited. Now from this node we can move 2 steps forward, but if we move 2 steps forward we are going out of bounds. So the other thing is we can move 2 steps backward, but if we move 2 steps backward we again reaches this 2 node that was visited earlier. So that's also not a good possible move. Now we also have a move from here 2 steps backward and we reaches this 3. Okay, now from this 3 we can have a 3 steps backward movement, but it is out of bound, so we are not thinking about that. But we have a 3 steps forward, and 3 steps forward we can mark this as visited. Now from this position we have only one position that can be moved, 1 step backward, 1 step forward. But if we see these 2 nodes, we already visited these 2 nodes earlier in past. So if we again comes up into that node, we will be again repeating these steps again and again and there will be no way that we will be reaching this 0 node. So at this point we will be returning false. So that's the idea. So here we can consider this in the form of a graph, a traversal, where there is the movement given us, that is from a particular node we can move to our neighbors that are I plus array of I and I minus array of I, and from there again we can move to our neighbors, that is I minus array of I or I plus array of I, keeping in mind that the visited nodes will not be visited again. We don't want that condition. Also we are not allowed to move out of bounds. So keeping all this in our mind, we can just apply DFS or BFS to yield our results. So let me try to implement the DFS here. So just a basic step: if array is equal to null or AR dot length is equal to 0 or start is less than 0, those conditions will not be there because it's already given in the constraint, but still we can return false. Okay, let's take the length equal to ARR dot length. Now we can create a boolean visited is equal to new boolean of length. Okay, and we can say we already visited this one. No, we can do that inside the DFS function. Okay, now we are going to do the DFS function, and this DFS will return whether we will be able to reach the node 0. Okay, so we will be passing ARR, we will be passing the start, and we will be passing the visited array. Okay, now this function will check whether we will be able to reach index with value 0. Okay, let's also pass the length, why not. Okay, so public boolean DFS of int ARR. Okay, that's our array in start, which is the starting position, or we can say our current position. Okay, this is more convenient. Then we are having boolean visited, then our length. Okay, so first start with the boundary conditions. Okay, so what are our boundary conditions? Our boundary conditions are: if our current position is less than 0, if our position is less than 0, or our position is greater than or equal to length, or we already visited, at that time we can return false. So that will be checked at the very beginning. So if if current position is less than 0 or current position is greater than or equal to length, or we already visited, if visited of current position, if any of these condition hits, then that's not a valid case, we can return false for that. Okay, that's true. Now if we reached the destination index, which is our destination index? The destination index is the index which is having a value 0. So if array of current position is equal to 0, just return true, because that's what we are looking for, whether we will be able to reach a position where it is having the value 0. Okay, if that's also not found, we are not hit with the boundary condition, we are yet to reach the destination, then there is still a possibility that going either forward I minus array of y, or I plus array of y forward, or I minus array of y backward, we may able to end up in the index that we are looking for. So first we need to mark the current position as visited. Okay, now we need to do the DFS, return DFS ARR. What are our two possible movement? Current position. From current position we can move plus current position forward. Okay, and also, and either this will yield a result for us, like either moving only forward, 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 forward. Sometimes we may get the result, but that's not only the case that we need to check. Going backward may also give us the result. So we can also say or DFS of ARR current position minus I missed something here, sorry, typo. Current position minus ARR of current position, okay, listed length. So what we have done, we have just created a Boolean array in order to track which of the nodes are visited, because if we again end up in a node that was visited earlier, then there will be no possible way that we will be able to get into the destination that we are looking for. So then we will be doing our depth first search. Okay, we are starting from a particular position. We will be moving the current position plus array of current position forward, or current position minus array of current position backward, and we will be just checking whether we will be able to end up with this condition. So let's try whether our approach is correct. Okay, it's returning true. Let's test for all the sample test cases. Okay, we are good now, and we can try for this one. Yes, so it's working perfectly fine. The same logic can be also applied for the BFS, like using the queue, just adding the elements into the queue. The elements that we will be adding will be, if it's possible to move I minus array of I, or if it's possible to move I plus array of I, then we will be adding I minus array of I and I plus array of I into the queue, and we will be continuing the searching until the queue becomes empty. If the queue becomes empty, we can just return false. Otherwise, the value, that is this array of current position value, will be captured inside the travels inside the queue. So that's the BFS approach. So here we can just can remove this visited array also. Okay, so how means we can just, it's given, like it's given non-negative integers, so we can also make a